Penetrating enemy airspace can be done more effectively if electronic attack assets are employed to help suppress the enemy's integrated air defense system. It is important to understand the capabilities and limitations of both electronic attack (EA) assets and the integrated air defense system (IADS). Software tools can analyze the impact of using EA assets by calculating survivability metrics and computing when and where the IADS will be effective. Software can generate jam plans for how to best deploy EA assets. Software tools can also create detailed route plans and emission schedules for the EA platforms. OR Concepts Applied has created such software as part of a small business innovation research effort called STEAM, Simulation Technology for Electronic Attack Modeling. This video highlights the uses and capabilities of STEAM. The goal for aircraft operating in enemy airspace is to accomplish their mission and return home safely. That means avoiding surface-to-air missiles, SAMs. Radar systems are typically needed to guide the missiles to the targeted aircraft. Aircraft such as the EA-18G can direct energy into a radar to make it more difficult for the radar to detect aircraft. Preventing radar detection makes it harder for the IADS to track the aircraft and can render SAMs ineffective. By taking advantage of EA, the protected entity, our aircraft, can operate in enemy airspace more effectively due to the temporarily suppressed enemy radars. In addition to using noise jamming, EA platforms can create false targets, which can make a radar show more aircraft than there are, or a larger aircraft than really exists. Planning an effective EA mission means considering many factors. The relative positions, that is, the geometry of the EA platform, the protected entity, and the radar affect how much energy will reach the radar, and thus the effectiveness of the electronic attack. In some geometries, the EA may be completely ineffective. There are other important considerations including range, the allocation of power, and the choice of EA techniques to deploy. The goal of an EA mission planner is to generate routes and jam plans that suppress threats in a way to best improve the effectiveness of the protected entities. The STEAM software developed by Orca has three primary uses: to analyze jam plans, to generate new jam plans, and to create routes for EA platforms. The first use of STEAM is to analyze jam plans. A jam plan indicates which EA technique is being used against which threat at a particular time. With this information, STEAM can generate figures of merit, or FOMs, quantitative measures of how effective the jam plan is. For instance, the total amount of radar exposure with and without jamming can be computed. An attrition model can be used to show the changes in survivability with and without jamming as well. The second use of STEAM is to generate jam plans. The software can analyze protected entity routes and radar geometries and generate a jam plan that makes good use of the power and techniques available on the EA platform. The STEAM software only adds jamming events when effective. For example, if the protected entity is not susceptible to a given threat, then there is no need to waste power jamming that threat system. The jam plan optimization methods incorporate three fairly sophisticated techniques: centroiding, walking in, and walking out. Suppose there are two threats that can detect a protected entity during its route. Centroiding is directing a single jam beam somewhere between the two threats to suppress them both. Walking in is discovering when two jam beams can be combined into one and still effectively suppress both threats. Walking out is when one jam beam can no longer suppress both threats, and two beams are needed. The third use of STEAM is to generate EA platform routes. STEAM is able to generate routes for stand-in, close-in, and decoy jamming. STEAM routes place the EA platform into geometries that can effectively suppress threats. Stand-in jamming can either be on board the protected entity, in which case it is known as self-protection, or it can be off-board, in which case it is known as escort jamming. Close-in jamming refers to EA platforms that get very close to a radar, such as the MALD-J. Decoy jamming refers to any type of EA platform that suppresses radars by using false targets rather than noise jamming. The standalone STEAM program has a user interface that displays routes, exposures, and jamming events. A traversal function helps one visualize the flyout of all the aircraft and to see the jamming events. A timeline on the exposure chart shows when exposures will occur and whether the exposure will be suppressed. The timeline is used to highlight current jamming events and what techniques and beams are being used against which threats. The STEAM Software Developers Kit provides programmatic access to its algorithms. This enables STEAM functionality to be incorporated into new and existing electronic attack battle management software programs. STEAM is used at the Virtual Combat Laboratory at the Air Force Research Laboratory at Wright-Patterson Air Force Base. It has been integrated into a high-fidelity simulation environment. STEAM is generating routes for EA platforms, creating jam plans, and analyzing the effectiveness of the plans. Orca is interested in having our modeling and analysis tools used in new applications, including EA battle management. More information is available on our website.